Once again to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls, I'm actually a person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below the purple glow. And folks, the show that we're going to be doing right now is by far my favorite. This show is completely live, so you're going to hear my voice for the next 30 minutes. This one we're about to see is called Tour of the Universe. And with Tour of the Universe, we're going to be starting off pretty close to the Earth, and then we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just to forewarn you, we're pretty small in the grand scheme of things, so just a heads up. But before we embark on this journey, I do have to go over some quick house rules just so that we're all on the same page. First off, folks, there's no food or drinks allowed in. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the planetarium as clean as possible. We thank you for that. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now's the time to put them away for the next 30 minutes, as these take away from the planetarium show experience, as this room's going to get quite dark. It kind of takes out the fun for being in the planetarium dome. And also, folks, if you need to leave early, the exits are always at the top of the planetarium, so always make your way up the stairs to exit. If you have trouble climbing the stairs, don't worry, we understand. Just remain seated. Once the show's over, we'll have someone escort you to a lower exit. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, well, there's a really quick and easy trick to help you. All you gotta do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, looks like we're ready to go. So I invite y'all to sit back, relax, and stare into the screen before you, because here comes Tour of the Universe. Alrighty, everybody. As I mentioned, we're starting pretty close at the Earth. We can see all the city lights down below. We're not exactly on ground level. Instead, we're starting a little bit above here at this really cool contraption called the International Space Station. We also like to shorten it by calling it the ISS. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct all different types of science experiments that they can't really conduct closer to the ground, which has a lot more gravity influence. And some of the experiments that they'll conduct up here are things like what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? Another one is where what happens when you try to spark a match in space? Does the flame act the same? Does that act differently as well with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After the year, they compare and contrasted the two. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, right now the International Space Station looks really big on our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. And if you've never been to an American football field, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in at the moment. That's about roughly how big it is. And also, this looks really far away from our planet Earth, but it's not too far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles in terms of California, that's not too far away. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. And what's really impressive is that this thing is going incredibly fast. It's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes and experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And to be honest, folks, this is as far as we put humans into space nowadays, only 225 miles above the surface of our world. The reason why, well, it's really expensive to travel into space. You have to build yourself a rocket ship or buy yourself one. Then you have to account for all the rocket fuel, and that's quite hefty on the wallet. And not only that, you have to account for all the food, water, all the air you're going to be breathing while you're out here in space. So the bill gets quite costly quite rapidly. So only 225 miles is as far as we put humans into space. But folks, the International Space Station is just the first stop in our tour of the universe. So now we're going to see it slowly fade away to all the city lights down below. In fact, before we lose track of it, I'm going to add a nice little orbital path so we can keep track of it as it slowly disappears. And it looks like we're hovering or flying just above Italia or Italy right now. And now, folks, we've zoomed so far out, we're now able to see our entire Earth. And I want to let you know that the space program that I'm using here inside the planetarium is something that you can go home and download if you want to give it a try. The space program that I'm using is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across the link where you can download this. If you don't put in the word project, you're going to get a link to a furniture store, so avoid that. And also, folks, OpenSpace is an open source program. So that means if you know computer language programming, you're able to add to it, and it's a whole lot of fun. Although, just a heads up, there's still a few bugs and glitches with the software. It's not completely finished, it's in its beta phase. And if we do come across any bugs or glitches, I'll point them out. Hopefully, we can look past them. Oop, here comes some data that's slightly missing, but that's okay. And also, folks, OpenSpace uses a whole lot of processing power and information. So if you've got an older computer, you may not want to download it. But if you got something new, like a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything, I never have enough storage space, we also have another great alternative called NASA's Eyes. Just like the human eyeball, just type in NASA's Eyes. You don't have to download anything. Just click a few links and you can fly through space, and it's so much fun. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. Now, folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the Earth, or surface of the moon. And they got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But that was the only brief presence of humans on another body in our solar system. Again, last time was 1972, so a little while ago. And what's really amazing, folks, is that here on Earth, when we're looking at the moon, sometimes the moon feels incredibly close to us. Feels like you can reach out your arms and touch it. But the moon is incredibly far away. It's about 240,000 miles away from our planet. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. And from here on now, folks, we're going to need to use a more useful measuring stick, because at this scale, using miles is kind of like using inches to describe the distances between cities, because space is so big. So astronomers instead use a more convenient measurement known as light speed. Now, light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly fade away. In fact, let me add some nice planet trails so we can keep track of them as we start to zoom away. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do 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 do. And also, if you have your flash on, please turn off the flash. It's lighting up the whole dome. We appreciate it. Thank you so much, y'all. Alrighty, folks. So now we can see our star, the sun. And folks, the sun is incredibly far away from our planet as well. It's about 93 million miles away from our planet. Whew, 93 million miles. That's a good distance away. And again, we're the third rock from the sun. So 1, 2, 3, that's us, Earth right over there. Sun's right there. 93 million miles between us. In terms of speed of light, that's not too far away. In order for sunlight to reach us on our planet, it only takes sunlight about 8.5 minutes at the speed of light. So not too bad. And this is a cool concept because if the sun was to turn off all of a sudden, we wouldn't know about it here on Earth for about 8.5 minutes. Because that last bit of sunlight would shine, cross that 93 million miles, and then all of a sudden the daytime would become nighttime on our planet. And again, folks, this is such a cool concept because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when we look at really far away objects in space, it's kind of like looking back in time in a sense, which is pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's do a quick crash course of what we got here. Right in the middle, we have our star, the sun, the biggest thing by far. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. Although a couple of them are really, really hot, and you wouldn't want to do that. And past the orbit of Mars, we have this really cool thing called the main asteroid belt. This is what it would look like if we were to highlight all the asteroids in our asteroid belt. There is a lot of them. And past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. And then we have Saturn, famous for its rings. And past them, we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto, just right in front, down below. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. So the Kuiper Belt is essentially a second asteroid belt past the orbit of Neptune, and you're going to mostly find out here icy asteroids and short period comets, comets that don't stray too far away from the sun. And so as our technology has improved and gotten better, we're able to find a lot more objects, much smaller, much further away from the sun. So who knows what else we'll be finding way out here in this outer part of our solar system. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction right over there. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, not too bad. But now, folks, it's time for us to leave our planetary scale behind. So now we're going to leave our solar system and the planetary scale behind, because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And we're zooming so far out now, folks, our star, sunlight, becomes another star among all the other stars in our star field. And Alpha Centauri is the closest star that just zoomed by us on the left-hand side. So we're right in the center of our screen. Alpha Centauri is towards the left. Again, 4 years at the speed of light in order for us to get to the next star system to us. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Folks, if you got on a rocket ship today, made your way over to Alpha Centauri, it's going to take you about 8,500 years. Whew, I don't think I could live that long. But let's stop and consider whether humanity has made its presence known, because now we're going to be stepping inside something called the radiosphere. And once again, folks, we're now looking at something called the radiosphere, and this represents the current limits on the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And for now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets just in the nearby vicinity to us, 5,000 other worlds besides our own. Now, our technology is not yet able to answer the question if there's any Earth-like exoplanets. New generations of astronomical instruments are devoted to that search, so we've got a little while before those are drawn up, constructed, and then launched into space. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, let's say we live in a star system on the far left-hand side of our screen. We find an alien civilization somewhere on the right-hand side. We shoot them a text message. Takes 60 years to get to them. They listen in, answer back. Another 60 years to get a response message. Folks, that is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But, of course, folks, planetary systems beyond the radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is constantly growing, but it becomes weaker as it does. And for now, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. Now, folks, we're looking down at our entire Milky Way Galaxy, the galaxy we live in, and I've got to ask, can anybody see their house from here? Yeah, we're too far away. It's not possible. And folks, our Milky Way Galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light just to cross it once. And our Milky Way Galaxy is so big, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within this small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave, I want to show you what it looks like from a sideways perspective. You're going to notice that our Milky Way Galaxy kind of looks like a big flat pancake in space. This is the plane of our Milky Way Galaxy, folks. And this is important because when astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of our Milky Way Galaxy, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. And folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture expands, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other as there's very few galaxies or voids of space. So we can see a nice galaxy clustering over here, some over here as well. We can see very few galaxies on the left-hand side or the top of our planetarium dome. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now that this picture that we're looking at represents the closest 30,000 galaxies to us in space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who worked at the University of Hawaii and compiled this amazing representation thanks to the work of dozens of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tully. But folks, we now have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew. And just to let you know, our large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned we live in a big flat spiral disk of our Milky Way? Well, if you were to line up our Milky Way galaxy, it will run right up down the middle. So right vertically up and down. And again, we like to point our telescopes galactically north and galactically south. And astronomers still wanted to make sure that there was galaxies through the plane of our Milky Way. So we have this nice purple survey of galaxies. You notice we were still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been mapped out yet. So it's just a matter of time. But let's continue pressing on, folks, because we're almost to the end. And now we're going to be encountering these really distant, faraway objects known as the quasars. Now, the quasars are going to be represented by nice orange dots on either side of the large-scale structure of the universe. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. So here we are, folks, at the very edge of the observable universe, and what we're looking at is something called the microwave background image, the cosmic microwave background image. You can also shorten it by calling it the CMB image. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this picture that we're looking at is the very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this is not your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to a large-scale structure to the universe, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over millions or billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards home, back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies, and let's make our return trip back to planet Earth, everybody. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, folks, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way Galaxy. We headed straight through our radiosphere. We're making our way to our star system, our neighborhood, in the vastness of space. And now, folks, we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound just in time for dinner time. And with that being said, folks, that's the end of our show. Thanks for stopping by, everybody.